in this synthesis technique, what we're going to do is we're going to synthesize a rocker output non-quick return. Okay, so here you can see is the rocker of the design. Okay, and this is drawn in position 1, and this is drawn in position 2. Now, what is typically given here will be say theta m, or the throw angle. Okay. So what is given here is the throw angle. Okay. So in order to synthesize this mechanism, okay, what we're going to do is choose a point. Okay. We'll call this point E. Okay, and that will be labeled E1. Now, then what we can do is we can use our compass. We can place our compass down here at D. Okay, place our compass down here and put it up here at E1 and draw an arc to this side. Okay, and this becomes point E2. Okay, so E1 to E2. Okay, follows this path. Now I can pick any point along this link. Okay, any point along this link. So we're going to pick an attachment point. Call that E. Draw that point. Two positions. Okay. The third thing is we're going to do is we're going to construct a line that connects E1 to E2. Okay, so we construct a line that connects E1 to E2, and that goes out into space this way and into space this way. Okay, so this is a straight line. Okay. We're then going to get the bisect distance between E1 and E2. You can do this in a variety of ways. You can use your compass and get the perpendicular bisector. You could use a scale and measure between E1 and E2. What we're going to do is get this perpendicular distance. Okay, so we're going to bisect that, and that becomes the perpendicular distance between E1 and E2. Okay, I'm going to jump down here to the steps 5. We're going to pick a point. We'll call it A along the construction line. So we're going to pick any old point A. Okay. That's point A. That's going to become a ground point. Okay. Back up here, and then just extend this line out. Okay. All right. Next thing we're going to do is we're going to draw a circle of E1, E2 by 2, right? So this bisector, so this is step 4. We're going to draw a circle of E1, E2 radius. So when we draw that circle of E1, E2 radius, I'll use green being construction line, that distance. Okay, that's a circle. You use your compass to draw that circle. Okay. Now what we have is now we can draw the link. In this position, so we've got the crank here. That's going to be B2, and then we're going to have the coupler, right? So we've got link L2, link L3, this distance is L4, and this distance from A to D is going to be L1. Okay? So we have this distance now. We've got L1 established, we've got L2 established, we have L3 established, we have L4 established. Now you can do things. You can check for Grashof conditions. Is it Grashof? Okay. You can go ahead and do motion analysis. You can look at mechanical advantage. Okay. But what we've just done is synthesized this 4-bar mechanism, non-quick return, right? So to go through these steps again, we pick this point E. We draw that point E in 2 positions, so E1 and E2. We construct a line from E1 to E2, this green line here. Draw it to the left and the right. We get the bisect distance between E1 and E2. And this bisect distance is really the length of the crank. Okay. We pick a point along that construction line. We draw a circle of radius E1, E2 by 2. And now we can synthesize the crank, the coupler, we've got the rocker. Once we do that, we now can go back to our analysis and check whether it's Grashof, do a motion analysis study, compute mechanical advantage. So that's the synthesis of a rocker output non-quick return.